Alright, so today we're going to talk about the scientific method. So what is the scientific method? It is a series of steps that scientists use to search for cause and effect relationships. It is a way for experiments to be designed so that only one item is changed to cause something else to happen in a predictable way. So key terms that we need to know. First is a hypothesis, typically formed in if-then statements. So if this, then stated. Then this. If this, then that. It should be logical sense and building on knowledge about an observation. A hypothesis is an educated guess that about what causes something to happen using few observations. It is an idea based on observations without experimental evidence. So we make hypotheses every day. You can look at a girl and a guy fighting and question what happened, what's going on, and then you can make a hypothesis. Well, it sounds like, listening to what's going on, if she cheated, then he has the right to be upset, correct? What you believe will happen, right? If she cheated, then he'll leave her. What are you testing to find? What are you testing to find out? So first is a theory, and a theory is an observation based on experimental evidence. It can be applied to unrelated data and new ideas. It is flexible and can be modified if new information is collected. Common examples of this are going to be evolution, the Big Bang Theory, and general relativity, right? They're a theory, they're not scientific fact, so if new evidence comes up, all of these theories can be changed. A law has been experimentally proven over and over and over again. The law I like to give an example of is the law of gravity. It has stood the test of time with little to no change. We can create predictions for different circumstances. If I throw my mouse up in the air, what is going to happen? It's going to fall to the ground. Every time I do that, it is going to fall. It is uniform and universal. So if I throw my mouse up in the air in Australia, it's going to fall to the ground just the same way that it does here. I cannot magically make my mouse stay in the middle of the air. I'm not breaking the law of gravity. These laws are not the same as in court, right? I can get a speeding ticket pretty easily, but I can't break the laws of gravity pretty easily. So, experiments involve variables and controls, and they have to be a fair test. To conduct a fair test in an experiment, you must only change one factor at a time while all other factors stay the same. So if you think about our glassware experiment for accuracy and precision, you can see, right, we only changed one thing, and it is what the container we used. So we used a beaker, an Erlenmeyer flask, and a graduated cylinder. Everything else we kept the same. So the changing factors in the experiments are called variables. The factors that are kept the same in an experiment are called the control variables. So some control variables were temperature of the room, who was pouring the water, how much water was poured in each container. So there are two different types of variables. We have independent variables, and these are the ones that are selected to be changed in the experiment. So if we think about the glassware experiment, the one that we changed each time was the type of glassware. So that would be our independent variable. A valid experiment has one independent variable to ensure that a fair test happens. Too many independent variables may lead to inconclusive results. Dependent variables are factors that are responding to the independent variable. So our percent error depended on which container we used. So the response depends on the independent variable, right? The dependent variable depends on the independent variable. consider it to be what is being observed through testing and measuring, right? We were looking at accuracy and precision. We were testing accuracy using percent error, so percent error would be our dependent variable. Think on it. A researcher wanted to see if music had an effect on heart rate. Identify the independent and the dependent variable. Right, the independent variable is music and the dependent variable is heart rate. If I wanted to use the information I had here, I could write a hypothesis. If music is played, then someone's heart rate will be different. If independent variable, then dependent variable changes. It is that simple. So, right, what is changing? The presence of music. Dependent variable, what are we observing? The heart rate. Our control variables we can refer to see what was changed. So our heart rate before the music was played, the person we're testing this on, things like this. Now the researcher wants to see what type of music has an effect on the heart rate. What is the independent variable? Correct, the genre of music. What is the dependent variable? The heart rate. And then some controls, right, the heart rate before the music was played. So we can use this information to write a hypothesis. If the genre of music changes, then the heart rate of the person would change as well. So other variables that could be controlled is the person undergoing the test must be the same to ensure the heart rate is at a resting rate, so I didn't go run a marathon before having this happen. The noise level of the music should probably stay the same, and then the environment that is testing. So sample size is very important. When doing an experiment using people, you must have a large enough sample size to eliminate personal bias. So in the music genre and heart rate example, you want to have a large sample of people to see the effect of some music on a variety of people. Everyone has different music taste, so if you take someone like me who listens to Slipknot and heavy metal on a daily basis, and you take someone who has never heard a Slipknot or heavy metal song in their entire life, our heart rates are going to be different, right? I'm going to have a lower heart rate from someone who's never heard aggressive heavy metal before. It's just how this works. You could even break it into smaller sample sizes, so we could look at age groups, so children, teenagers, adults, and the elderly, or groups of people that prefer music genres, so people who like heavy metal, people who like country, people who like rap, so on and so forth. So now that we've looked at different key terms, things that are important to the scientific method. So we have 6 steps, and the first step is to ask a question. How, who, what, when, where, why, and how. For a method to work, the question has to be about something that can be measured. So, how many people in my classroom are wearing a black t-shirt today? So, it can be counted. I can count how many students are wearing a black t-shirt. Do your background research. I can go research what is the average amount of people who wear a black shirt in a day. So I can use the library or internet tools to help me find the best way to plan my experiment. Please, for the love of God, never use Wikipedia. It is always wrong. Be sure to do your research so you can avoid repeating past mistakes. Construct a hypothesis. It must be stated in a way that can be easily measured. Must help you answer the original question. How many students are wearing in a black shirt in my classroom? How popular is a black shirt? So if a student likes to wear black, then they will wear a black t-shirt. That's a really bad example, but if this happens, then this will occur. So an experiment is then I do an experiment. You test whether your hypothesis is true or false. It should be able to be repeated. So I should be able to do a test multiple times. It must be a fair test, so I can only change one variable. And a good experiment should have an independent variable, a dependent variable, and other variables that are held constant. and then a control. So what is the standard basis? And then we analyze our data. So we review the data we've collected and compare it to our hypothesis. Does it support or not support our hypothesis? Regardless of the outcome, you should repeat your experiment to make sure you did not get a false positive, or if you need to tweak your original hypothesis and test it in a different way. And then we report our results. So we can create a final report or display board to show how you have come to your conclusion. So in summary, you have your purpose and question, then you do research, and then you hypothesize something, and then you experiment, then you analyze the data, you write a conclusion, and then you get published. And getting published is super important, especially in the scientific field. That is all I have for you today on the scientific method. I will see you next time. Bye.